how does AI actually think? Today, we'll break down the fundamentals of neural networks, the core of modern artificial intelligence. First, let's talk about the foundation of neural networks. A neural network is essentially a system of artificial neurons designed to process information in layers. It's modeled after the human brain, but instead of biological neurons, it relies on mathematical functions. This brain have a few layers. The first one is input layer, which receives raw data like text, images, or audio. The second one is hidden layers, which processes and extract patterns using weighted calculation, which I'll talk about later. The third one is output layer, which produces the final decision, for example, image classification or text prediction. Now let's talk about how neural networks learn. Step 1 is processing input data. Neural networks start with raw data, millions of text samples, images, or audio records. Step 2 is forwarding propagation or prediction processes. The data moves forward through layers of neurons where each one applies a weighted calculation, sums up the results, and runs them through an activation function to determine significance. Step 3 is error calculation. In other words, evaluating accuracy. Once the network makes a prediction, it compares the results to the actual answer using a loss function. And step 4 is backpropagation, or in other words, adjusting the model. The system then fine-tunes its weights using gradient descent, minimizing errors over millions of iterations until it produces highly accurate outputs. And now let's talk about neural networks in action. AI's thinking process depends on the type of neural network. There are 4 types of neural networks. First one is feed-forward neural networks, which is simple networks where information flows in one direction, used for basic classification tasks. Number 2 is convolutional neural networks, used for images. They detect features like edges and textures. And number 3 is recurrent neural networks, used for sequential data, for example, speech or text. They remember past inputs. And number 4 is transformer networks. Advanced models like ChatGPT use attention mechanisms to process text efficiently. Convolutional neural networks, or CNNs, are behind facial recognition, autonomous vehicles, or even medical diagnostics. By detecting patterns in images, they recognize objects with near human precision. Large language models like GPT-4 use transformer networks to process text in context, enabling real-time translation, advanced chatbots, and AI-powered writing tools. Neural networks don't just analyze data, they create. Models like DALL-E and Midjourney generate images from text, while AI-powered music systems compose original pieces. But what are the limitations and misconceptions? Despite their complexity, neural networks don't think like humans. They don't understand concepts. They recognize patterns and optimize responses. And in the future, AI development is accelerating with advancements in self-learning models and neuromorphic computing, which aims to bridge gap between artificial and biological intelligence. Neural networks have transformed how we interact with technology, but they're still far from human intelligence. The real question is, how close will AI get? Share your thoughts in the comments. For more in-depth AI insights, subscribe and stay ahead of the future.